back to my channel Kuluru Vineeth. So today I'll continue the arrays playlist. So today's question is sorting an array consisting of zeros, ones and twos. Okay. So let's take an example here. So this is what the example looks like. We are given an input of an array consisting of 1 comma 0 comma 1 comma 2 comma 0 comma 0. Okay, and then our output should be, we should sort the above array, that is the resulting output should be 0 comma 0 comma 0 comma 1 comma 1 comma 2. Fine, right? The question is clear, right? So the as we are already told that the array will consist of only zeros, ones and twos. So the coming now to the intuitional approach, what I would say is we can keep track of the counts of the zeros, ones, twos, and then push all zeros to the first and ones in the middle and two at the end of the array. Okay, so let me write down that approach. Okay, fine. So this is approach 1, keeping track of all counts of zeros, ones and twos, and let me name this as the approach 1, and here input will be integers array and we have to return is the integers array. Now let's take the three variables to keep count of the zeros, ones and twos respectively. Okay, so zeros count and ones count and twos count, and now we will loop on the given input array. Okay, so that is when num is 0 we will increment zeros count, if it is 1 we will increment ones count, if it is 2 we will increment twos count. Okay, fine. So from this loop we got the count of the zeros, ones and twos. Now again let's write one more loop so that we can push all zeros to the first of the array, beginning of the array, and twos to the end of the array. Okay, so that is in nums dot indices when, so here I will first use the above, that is zeros count is greater than 0, and here what we will check is we just have to push to the array, right? So here I will take this and make this as a 0 and decrement the zeros count, and do similarly for ones count and twos count as well. So that is ones count is greater than 0, make that nums of I as 1 and decrement that ones count. Okay, and twos count, if twos count is greater than 0 and make that nums of I as 2 and decrement the twos count. Okay, so finally at the end of this for loop we'll be having an array consisting of zeros, ones and twos in the sorted order. Okay, so then we will return the nums. Okay, so this is the approach 1. Now coming down to the time and space complexity, as we see we are using just temporary variable, so it will be in a constant space order of 1, and coming down to the time complexity we are using two loops, that is order of n plus n, so it will be order of 2n, ignoring the constant number, so the time complexity would be order of n. So let me write down that time and space complexity. Time is order of n and space is order of 1. About the approach 2, we can achieve the same solution using the 2 pointers, that is you writing a two loops again. First loop is to the target of the first loop is to move zeros to the beginning of the array, and second loop target is to move the twos to the end of the array. Okay, it will be better clear if I start writing down, so that it will shape out what I was talking about. So let me write down that. So it has approach to using two pointers. Okay, so let me name this as the approach to, and the input remains the same, and output also, return type also remains same. So here we'll take two pointers first, that is name them as the left and right. Okay, so 1 second, name them as left and right, and now write first loop to move zeros to the beginning, to move zeros to the beginning of array. Okay, so we will write this while left is less than right. So here what I will do is this one, if left the pointer is pointing to 0, so we will just increment the left. So for that I will write this one more loop here, left is less than right, and nums of left is equals to 0, we simply move towards right. Okay, that is incrementing the left pointer. And one more thing is, if again left is less than right and nums of right is not equal to 0, we will decrement that also to the left side. Okay, so now, so if this is not the case, then we will swap the left and right pointers. So let me take the temporary variable and store nums of left, and here nums of right will be nums of nums of left would be nums of right, and the nums of right swap. Okay, so then at the end of this while loop we will have all zeros to the beginning of array. Now the one more target of ours is to move twos to the right side of the array. So let me reinitialize right to end of the array, and again write this let me write comment as well, to move twos to the end of array. Okay, so let me write the while loop, same here, while left is less than right, and now here is if nums of left is equals to 1, so that we want ones to be in the middle only. So now the left will be pointing to the 1 value, so we will just increment the ones. Okay, we'll just increment the left pointer, nums of left equals to 1, so left pointer increment, and again if while left is less than right and nums of right is equals to 2, we will just decrement the right pointer, because 2 is already at the end of the array, right? So nums of right equals to 2 right pointers, else we will swap left and right. Okay, so I will store nums of left is equals to nums of right, nums of right would be 10. Okay, then finally at the end of these two loops the nums would be sorted in the form of zeros first, ones in the middle, twos at the end of the array. Okay, then we can return nums. Okay, so this was the approach to using two pointers. Now coming down to the time and space complexity, since we are looping the array at most twice, so the time complexity would be order of n and space complexity would be order of 1, since we are using just variables to keep track of the pointers. Okay, so let me write that time is order of n and space is order of 1. Okay, and yeah, so that was the approach 2. Well, is there any other approach again to achieve the same solution? We could do counting sort to get the solution done, same as the approach 1, but here we use the counting sort of array size as 3. So let me write down that one as well. Okay, so that is approach 3 using counting sort, and name this as approach 3, and input remains same and return type also remains same. And here now we will take the counts array, which is of size 3, that is to keep track of zeros, ones and twos count. Okay, now I'll loop through input array, and here we will increment the nums. We'll increment the we'll keep track of the zeros, ones and twos using the above int array we have declared. Okay, now we have the counts of it, so we have to create an array which will give us the array in the form of zeros, ones and twos. Okay, so here I will just do this way, and for j in 1 until ones are fine, we have to just increment this and put this. Okay, simple and straightforward. Okay, here it has to be 0. Okay, so it's a 0 indexed, right? So, and finally return that nums. So now this nums will be sorted in the form of zeros, ones and twos. Okay, and now coming down to the time and space complexity, since we are its array size is constant of 3, we can ignore, so the space again would be order of 1, and here also inner loop it's of and this runs counts.indices just for 3, so we could also ignore this since it's a constant number, and here order of n. Okay, so time and space complexity would be order of n and order of 1 respectively. So let me write down that time is order of n and the space is order of 1. Okay, now these are all the 3 approaches that we could think of for this question. Now let me write down the main function and start executing each approach and compare the output of each of them. Okay, so that is, and first create the object of the above classes I have created, and sort. Just a second. Okay, so and the example also I'll take first. Let me write down print approach 1 and call that as approach 1 function. Okay, that is approach 1 and int array of, let me take the same example as I have given here. Okay, and use that. Now we will just iterate through the approach 1 array and print it. So do the same for approach 2 and approach 3 and see what the output looks like. Just change the names to approach 2. Here also to approach 2, and here to approach 3, approach 3, and approach 3. Okay, fine. So now let's execute and see what the output looks like. Well, yeah, let me print a line here. I always forget. Okay, so now let's print. Yeah, so there we go. As we see, the output of approach 1, approach 2 and approach 3 are same, which are sorted. So that is what exactly we needed. Yeah, so this is it for this video. Thank you so much for your love and support. Keep watching my videos. There will be a lot more content coming up on this channel. Yeah, thank you.